So will you be able to confirm if you can actually see and hear us, and of course view the slides on the screens by sending us a thumbs up on the chat box. Again, by sending us a thumbs up to confirm if you can actually see and hear us from your end. Thank you so much.
Thank you, Marvin. Thank you for putting such a nice presentation. So I really appreciate your effort. So am I
Okay,
audible?
so let's just let's wait. Okay, thank you so much. Thank you for sending us a thumbs up. Okay, that's great. Thank you for confirming. Thank you so much. And yep, so a little bit of housekeeping. Okay, so we would like to request everyone to have a laser focused attention to this webinar because we have a very interesting topic. So as you can see on your screens, we would like to request anyone to turn off your notifications so that you can focus on the webinar. So instructions are on your screen right now. And then we would like also, if you have any questions to Dr. Vishal and of course to us, to me, you can just share it, post it in the Q&A section on top of your screens. Okay. So for common questions and FAQs, so everyone who actually registered will receive a copy of the PDF slides and of course the link to the video recording in the next 2 business days via email. So please monitor your junk mails because it usually goes straight there. So just kindly monitor that one. And of course, for those who will be staying with us until the end of the presentation, you will receive a digital copy of your attendance for today's technical webinar. So basically, we will be posting the link and the QR code after the presentation. It will actually direct you to the survey. And of course, once the survey is completed, you'll be able to get your certificate in the next 4 business days. Okay, thank you so much. All right. So yeah, about EIT. For those who are just, recently just attended our webinar about EIT. So we are an education provider based in Perth, Western Australia. We also have a campus in Melbourne, and recently we just opened our campus in Brisbane, in Queensland. So we specialize in engineering courses. Okay, we are one of the institutions that specializes in engineering. And we deliver wide range of programs, starting with our professional certificate courses, diplomas, advanced diplomas. We have our undergraduate certificates, bachelor's, graduate certificates, graduate diplomas, masters, and of course, the highest level Doctor of Engineering. So these programs are industry-oriented programs to ensure that you have a cutting-edge skills that are valued by employers. And then we make sure that the program content remains current with the rapidly changing technology and industry developments. Okay, some of our programs, vocational and higher education programs, are nationally recognized by the Australian government, and we have programs as well that are recognized under the 3 engineering accords, namely Dublin, Sydney, and Washington. So these programs are being delivered to us by industry experienced lecturers like Dr. Vishal here, and then we also deliver this on a unique delivery methods using live webinars, live and interactive webinars, international pool of extra lecturers, and dedicated learning support officers, and state-of-the-art hands-on workshops and remote laboratories and simulation softwares. Okay, so why EIT? Okay, as you can see on your screen, we top on surveys. Okay, number one in Australia, Australian provider for student overall satisfaction in postgraduate engineering programs. We also top number one in as a Australian provider for graduate and full-time employment for undergraduate engineering programs, and both the top three for education experience for undergraduate engineering programs, and of course, student support for postgraduate engineering programs. Okay, so yep, these are the awards as you can see on your screens. We have been awarded in 2024 as an Australian export for the Australian Export Award for International Education and Training. Okay. All right. So for today's topic, the topic would be the fourth industrial revolution, key technologies driving change. This will be discussed with us by presented to us by Dr. Vishal S Sharma. He is our senior lecturer here at EIT with over 25 years of experience in advanced manufacturing technologies, including 3D printing, machining, machining, conditioning, monitoring, and industry 4.0. Okay, before joining EIT, he served as an associate professor at the University of Witwatersrand and in Johannesburg, South Africa. And he also a where he is also currently visiting professor and an NRF rated researcher there. He also held the position of professor in the Department of Industrial and Production Engineering at Dr. B&R Ambedkar National Institute of Technology in India. Okay, Dr. Sharma has published over 120 scientific papers, which has been cited more than 5,000 times, achieving an H index of 40 on Scopus. He has been recognized as top two researcher globally for 3 consecutive years, according to Stanford study. In addition to his extensive publication record, he has supervised 13 PhD and 28 master students. Okay, organized 7 international conferences and edited 4 special journal issues, authored 4 books with Springer Intelligent Manufacturing, Alexa Engineering Journal, International Journal of Mechatronics and Manufacturing System, Advanced Manufacturing Journal, and Proceedings of the Institution of Mechanical Engineers. Um, Part C Journal Mechanical Engineering Science, or SAGE. All right. Thank you so much. And I would now give the floor to our presenter. Please help me welcome Dr. Vishal S. Sharma. Dr. Vishal, thank you.
Thank you, Marvin, for this wonderful introduction. Now I'll be taking the control. Uh, Marvin, can you like slides is not appearing?
The slides
S- yeah, slides are not appearing. Just can you
from your,
please see? Yep.
let me see. Okay. It's actually appearing from my end, Dr. Vishal. Would
Yes,
you be
I
able to
can
take
see.
control again?
Yeah, let me do it. Yeah, take control.
Mm-hmm.
Uh, I'm able to take control now. Yes, 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 I can. I can do it
You
now.
can see it
Yep.
now. Okay, that's great. Thank you.
Okay. Now, thank you for this wonderful presentation, and really, I appreciate your effort in organizing such a wonderful event. So, welcome all the learners. I can see that learners are joining from all across the globe. It's a really wonderful presentation and webinar. Really, a lot to learn what is happening latest in the technology. So, here is the agenda that I will cover in today's session. So, I'll be covering about the key technologies that are used in Industrial 4.0, and then towards the end, I'll be talking about what are the research topics. So what you end up getting in this presentation is here. So clearly, after attending this presentation, you should know what are the key important technology changes that are happening at the moment. And I'll also give a few examples. Along with that, a more important thing is the key research opportunities in case you want to pursue your master's or your Doctor of Engineering programs. So I will also touch upon what are the key research areas that you should be focusing on. This is quite important here in this session, and also why it is important because I want to stay up to date in this competitive world of industry. So what skill set I need to have in order to still stay relevant in today's industry. So these are few things that you'll be getting in today's session. All right, so let's gear up with the session. So during the presentation, I'll be asking you a few questions also. Feel free to use chat box to reply. And also, if you have any question, you can write. Uh, so you can. So guys, am I audible? Can you please show me thumbs up or just post something in the chat
Yes,
box?
can we
Yep.
request
Okay.
everyone? Okay. So for
Okay.
those who have
Thank you.
having issues with the presentation, try logging out and rejoining, and let us know if the issue persists, and we'll check with it with the marketing team. Thanks.
Okay, thank you. Thank you. Sorry for this short interruption, but anyhow, let's gear up for this session. Uh, okay, so I'll be asking you a few questions here, and feel free to give a reply. And also, if you have any question, you can post the questions in the chat box. So I'll be taking a look at all those questions, and whenever I feel it's appropriate time, I'll reply that also. Okay, so what do you think will be the most important for engineers and professionals, skill set most important in 2023? So most of you are right. So we should have problem solving capabilities where the most important thing is interdisciplinary thinking, not focusing only on one domain. That is the key thing here. Now, coming to different industrial revolutions, you can see on this slide, these are different industrial revolutions. In each industrial revolution, one technology was something which was quite prominent and it led to different technological changes. For example, in the first industrial revolution, which happened at the end of 18th century, it was the steam power which was prevalent, and it led to other changes, other developments in industry. Similarly, in the second industrial revolution, which we had in the beginning of the century, it was the electricity. And can you point out what was the prominent technology that came into existence during the third industrial revolution? What was the key technology which came into existence? If you can use chat box for replying, it was the programming devices, computer and programming came into existence. So because of that, we got PLCs, programmable logic controllers, CNCs, and robotics, all sort of things. Now we are saying from 2014 onwards, uh, 2014 onwards, we are in a domain which we say it is a domain of fourth industrial revolution. Now, what is the key factor here? So one thing you should keep in mind that whatever we developed in the previous revolutions, we are carrying it forward. We are not dropping it there. Basically, we are carrying it forward. Automation was a key domain here in the third industrial revolution, as we have CNC machines, PLCs, things like that, robotics, all programmable devices. Now, in the fourth industrial revolution, it is all these devices are having enhanced capabilities. And what is that capability? Connected. They are all connected to each other. This is the enhanced capability, and this is what we say is nothing but it is the fourth industrial revolution. Now coming to this one, this slide, it actually tells what is happening in a typical industrial scenario now, in a typical factory which is up to date. Now, I'm not saying it is the fourth industrial revolution. So I'm saying I'm not saying it is industry 4.0. When I say industry 4.0, that is a basically it is linked with Germany because they give this concept industry 4.0, and in Europe it's prevalent. They use this terminology industry 4.0. So I'm saying fourth industrial revolution or third industrial revolution so that I remain neutral to any country. So this is the terminology which is neutral for IR, fourth industrial revolution. But each country they have their own equivalent which they use in their country, which they say that it is equivalent to the fourth industrial revolution. Now, coming to what is the key factor here? The key factor is so all the machines and devices, they are connected with each other. They are connected with each other using internet and internet devices. All right. So here in a typical environment, if you see what we have here we are having robots. And you know very well where we use robots. So in any if something which is done earlier manually, if it is having a 3D, so 3D, so first D stands for dull, dangerous, and dirty. If there is some application which is dull, dangerous, and dirty, so we would like to replace it with the robots. So we put robots there. They are doing all this task, and need not to say that robots are programmable devices. Now here, if we see this one is a big data technology, I will be talking more about this in the subsequent slides. And then we also have here is here we are having the cloud computing services, and then we have big data technologies and wireless communication. So we are making use of wireless communication here. So a lot of flexibility. And then we have we can see here at number 4, we have embedded systems. So what do you mean by embedded systems? Now, embedded systems are basically small computers which reside inside the machine, and it help control and take actions and monitor. And basically, they are controlling things in real time. So that is the embedded systems used for condition monitoring here and control, of course. And then we also have smart storage devices. So the system knows where everything is and it manages space well. So I will give you one example of this in the subsequent slides. And here, the most important bit, rather, it's the last one, but not the least one. It is the flexible and intelligent logistics systems. Logistics, not only in the company, but logistics outside the company also when product is to be delivered to the customers. So you can see here, this is the overall setup of industrial 4.0, a company which is compliant, which is using latest technologies, and this is what Industry 4.0 means. I hope up to this point, is it clear? Some acknowledgement from your side is really appreciated, learners. Thank you. Now coming to the core technologies, here these are some of the technologies which we have, and I will be addressing them one after the other in my subsequent sections. So we'll start with the additive manufacturing, then IoT, AI and machine learning, advanced robotics, AR, VR, and cloud computing, cybersecurity. Thank you. Thank you for confirmation. Now we all know about additive manufacturing. So additive manufacturing, one of the type is 3D printing, and this is in contrast to subtractive manufacturing. The conventional manufacturing, we say it is subtractive manufacturing. Now 3D printing, it has got a lot of attention over the last 10 years, because now because of one reason, that design, even any complex design can easily be manufactured. This is one reason. Another reason is now we have technologies. On using those technologies, we can print polymer materials, metals, composites, and even ceramics. So a lot of materials can be 3D printed these days, and because of that, it has gained popularity. Now, having said that, now what is new coming up in this technology? So you might have heard this word digital twin. So this is something which is new coming up in 3D printing, or not only 3D printing, but in other sectors also. So for example, if I want to have a digital twin of 3D printing, and 3D printing, what you see is this is what is happening in the practical scenario. What is happening actually, digital twin is something like what is happening in the virtual domain. This is what is happening in my CAD domain. So digital twin, I'm having, it is like having a replica of the actual situation in your computer, and they are all connected. They are connected through sensors and real time data exchange is happening. For example, if I want to move, say if I want that bed should heat up to a certain temperature, I give a command here in the digital domain, and immediately it will be reflected there. And if I make any change on the machine, actually that is communicated back and it is updated in my digital twin. So what is the advantage? Suppose I'm not having the actual machine, this is not available. Now still I'm having the digital twin of the machine, and I can do all my trial testing experimentation on using digital twin. And once I'm satisfied with the quality of product that I get out of 3D printing, trying everything on the digital twin virtually, then only I go for experimentation. That way I'll be saving a lot, especially if now we know that polymers, when we are talking about 3D printing in polymers, it is quite established, but in metals, still we have not yet reached a stage where all the things are quite well established and well developed. So when it is especially for metals, we can definitely create digital twins, which is basically a virtual machine and real-time data exchange is happening through sensors and other things. Now, what is meaning of real time? It is not instant. It is not everything is happening instantly. There is a time lapse everywhere. So real time does not mean it everything will happen instantly, but there is a time lapse. And again, it depends upon application to application. In some cases, it could be just one under something which is happening under 1 second, as I can say it is a real time. For example, when you go for bank transaction, the ATM, when you put your card there, your ATM will check your balance within 1 second. That's good enough for my application. So the 1 second, anything less than 1 second is real time in case of a banking application. But when it is a machine, it could be 10 millisecond also, depending upon what is the application. For autonomous cars, it could go even less, so less than 10 millisecond. So again, everything depends upon your application, but the key point is the digital twins are the copy of actual machine and they are communicating with each other in real time. All right, with that information in the backdrop, I would request learners to please log in your option here. So how can a digital twin technology enhance additive manufacturing process? So you can see this is a physical process, a virtual model, and real-time data exchange is happening. And real-time, not only data exchange, but we are also controlling the process. Controlling the process for what? We are controlling it to get the best quality. Definitely, yes. Thank you so much for your response. All of you are fabulous. That's right. Option C is the right option. Thank you. All right. So going further, IoT, Internet of Things. Here, here what we are doing, we are connecting physical objects or devices through sensors, and the data exchange is taking place through internet. So that is why, so you are having things which you are connecting together with internet. So that's why internet of things. Just very simple example, the wristwatch sitting on your wrist is basically it is monitoring your temperature or blood pressure, and whenever it goes up beyond a certain period of time, it can establish link with the hospital and make a booking for you there if that application you have. So you see different devices, they are connected together each other with each other. There is no human intervention in the process. So they are connected with each other through sensors, and data exchange is happening via internet. And if the same technology is applied in industrial scenario, it is called IIoT, Industrial Internet of Things. One example. So one example you can see here. So in the backdrop, again, this is a 3D printer, and I'm able to control 3D printer using my mobile. This is fantastic application of IoT, Industrial Internet of Things. How it can be done? It can be done very easily. If you want to work in this domain, you can do it quite easily, and you can use one services which is called Octoprint. Now, Octoprint is a open source web interface which allows you to control and monitor 3D printers. And what you need to have, this is a web services. You need to have just one Raspberry Pi, which you will insert in the USB here. That's it. So now you have a connection. USB, Raspberry Pi is a microcontroller, a controller that you fix here in USB, and it will establish the entire data of the machine will be available on this website, and that website you can open here on your computer on the screen. maybe mobile in this case, and whatever are the process parameters available on the control panel on the actual machine, all those will be available to you on your mobile. So what is the advantage? Sitting anywhere in the world, I can see what is happening, what I'm printing on my 3D printer. This is just one example, not only one. I can have multiple machines sitting in my workshop, and I can monitor status of each and every machine there. Now, this is what is industrial Internet of Things. You see, this is the power of industrial Internet of Things. Okay, with that, let's try to do this quiz. Please log in your options here. What is the main function of IoT in a smart factory? Thank you guys. Really appreciate your effort. Really, thank you so much. Now coming to the next bit, it is artificial intelligence and machine learning. What is that, and what is the difference between these two? Artificial intelligence, I would say that is the overall big umbrella. And under this umbrella, one tiny part is machine learning. So now for machine learning, I can give you one example here. So I want my mobile to recognize only my voice. So what I do? So I speak and I record my voice here, and basically what I'm doing, I'm training my device on my voice. This is I'm training it with the known data. So this is my past data. So machine learning, you are training your devices. There are different algorithms which you can use for machine learning, and everywhere one thing is common: you should have past data available with you. Then only you can go for machine learning algorithms. So what is my goal in artificial intelligence or machine learning? My goal is I want machines to act like human beings. So they should learn, plan, reason, say have knowledge sharing and problem solving capabilities. That is my goal in artificial intelligence. And in machine learning, we heavily rely on past data, whereas the bigger umbrella, artificial intelligence, is something on sitting on the top. And here we can also have expert systems which do not rely on the past data. So artificial intelligence is the big umbrella. Under that umbrella, we have machine learning. Now, mind you, having said that, AI, it may or may not use past data, but machine learning will be using past data. So that is a basic difference between these two technologies. Okay, thank you so much for your input. So with that information, please attempt this quiz. Which of the following statements best describes the relationship between artificial intelligence and machine learning? Thank you guys so much. I really appreciate your effort and response so quick. Really appreciate that. Thank you so much. So yes, you're right. So machine learning is subset of AI. Thank you for your response. Now going further, advanced robotics. So robotics, we know, each one of us know why we are using robots. As I said earlier, also, whenever it is 3D process, any process is dull, dirty, and dangerous, replace it by robots. But this is just half part of it. Robots are programmable devices, but when I am linking it with artificial intelligence, then it becomes advanced. So advanced, it will become advanced because I will link it with artificial intelligence. Now my robot will behave like a human being, an expert in the domain. So whenever this happens, then it is advanced robotics. Otherwise, if you are simply using robots, that is a programmable device. And these days, a lot of collaboration is going between. There is a collaboration like humans and robots. They work together hand in hand, and this situation is called, it's like you are when there is a collaboration between humans and robots, so they are called cobots, robots that collaborate with human beings. And this is what is happening these days. And when they're working side by side with along with the human beings, there definitely they require artificial intelligence. All right. So just to keep you engaged in the process, another quick question. Which of the following is an example of advanced robotic systems? All right. Thank you so much. Really appreciate your effort and responsiveness. Thank you so much. Really. So collaborate, cobots is the answer here. The next bit, which is quite interesting, and I'm really excited about this bit, is augmented reality. And what is this? So one word is important here. So it is a reality. So reality and augmented, you are enhancing that reality. For example, if you take out your mobile and grab the image of a street, and what you can see is the reality. On the background, you can see the image of the street, but on top of that image, you get an additional digital layer of information. So you can see here digital layer of information, and what that information is, it is telling me this is a particular building, this is bus stop, this is coffee shop, things like that. So I'm able to identify what where I am and what each building is. Maybe it will be useful for me. This is a normal situation which you can, this is a normal thing which you can do with your mobile. And this is a reality, picture is a reality, and you are augmenting it, you are enhancing this reality with the help of a digital layer sitting on top of it. Now, how it is used in industry. So here is one example. As a maintenance guy, I want to see what is a particular machine, and I want to carry out maintenance. So what I do, I take my laptop or tab there, I grab the image and this augmented reality software which is sitting on top of it. It will tell me what are various parts of this motor, and it will also tell me how to open this motor in order to carry out maintenance. This is a fabulous thing, really superb thing that we can do with as a maintenance guy, quite close to my heart, because being a mechanical engineer, I would love to do it, because with the passage of time, the information is lost. So this one is really helpful. So augmented reality is really helping us, especially the maintenance guys, to perform the maintenance and as quickly and efficiently. All right. Uh, so I will, this is one thing. And next one is even more interesting. Now, this one is virtual reality. So virtual reality, so you see here, this student, he's wearing headset, and with that, he is working on some assembly. Now, this is everything is happening in virtual environment. So this is not a reality. It is everything is happening in virtual environment. And advantage of doing like this is, if you can't go to a particular place, or if we don't have facilities, then we can still learn all those technologies sitting in my on my table chair and on the table chair, and use this technology of virtual reality. Now we can combine these two together also. So there are a number of advantages of doing that. So I will not go into that detail at the moment. So with that information, so augmented reality, it is reality, digital layer sitting on top of your reality. And virtual reality, this is not reality, but you have so you're trying to create reality virtually. It's a virtual domain, CAD domain, and you can perform, say, you can learn many things. And these both these technologies are used extensively for training manpower. Even this can be used as to simulate an environment where you actually cannot go and you want to perform some maintenance. All right. So with that information in mind, up, can you give reply to this question? Which technology is best choice for training workers to operate complex machinery in factory? Thank you for your response. So this one is this is the right option, and sometimes it is also called mixed reality. So this is also called mixed reality. So one example I can give you, I studied in France, and there, they there was one monument where that half of the monument was destroyed during French Revolution. So what they were doing now, they were putting panels. These are big panels which they're putting, and if you point this panel towards the building which is actually there, it will show that building. But when you're pointing it towards something which was destroyed during the revolution, it will still show the complete picture that what it looks like. So this is the mixed reality. Not only that, it also comes with a digital additional information sitting on top of it, and that is what is what. So it is all the monument is properly labeled. So definitely this is the latest technology, and really industries are making use of this to march forward in the industry 4.0 or fourth industrial revolution. Okay, so now this one is even quite excited. So I'm quite excited about this cloud computing thing. So what is cloud computing, and why there is need to go for cloud computing? So you can use your chat to give me reply on this. Okay, so cloud computing. First thing is this we cloud computing is required for data. I don't require cloud computing for normal data. So having said that, now what this cloud computing is doing, uh, now cloud computing is required for storing, managing, and processing the data which I can access anytime. It is like why I need to use my laptop to which should with the laptop while the laptop should have higher storage and higher processing capabilities. I can use a normal laptop and I can connect to my internet, and everything whatever I'm doing it on cloud. So this is something what we do in cloud computing, and we use it for cloud computing. So we use it for big data, not for normal data. Now, what is difference between normal data and big data? When we say it is big data and when we say it is a normal data, just to give you an example. So if a retail shop store, it keeps sales data in Excel sheet. So data is maybe 10,000 rows. So is it example of a big data or normal data? Can you tell me? Is it example of normal data or big data? Definitely, it is example of a normal data. So sales store, a retail store keeps sales data in Excel sheet. Now, what is big data? So think about Amazon store, billions of transactions, clicks, product reviews, uh, yes, so this is product views and product reviews every day. So lot of data, huge data. So this is something which you cannot process on your normal computer. You can't store, you can't process. So in general, we say there are 5 V's, and because when you have these 5 V's, this is how you distinguish between normal data and big data. And what are these 5 V's? Very simple. First V is volume. When you have huge volume, so how much is the volume? So as a thumb rule, we say that more than say 1 TB of data, terabyte of data is we say that is a huge volume. We can't handle it with normal. No, it is now big data. Second V is velocity. So data is produced at a very high rate. Third one is variety. It is coming from different sources. Fourth one is the veracity. Veracity means the data is noisy data. And the last one is value. Value means I should be able to get something out of that data. And value means I can't get direct inferences. So I need to do some special processing to find out useful insight. So then only I'm able to use that data. So if you meet all these five requirements, if your data is having these things, then we certainly say this is something application of big data. And in big data, we require cloud computing. And these are some of the companies, they are providing services for cloud computing. So Google Cloud is one platform, Oracle Cloud, AWS, Microsoft Azure. These are the companies they provide you they provide the resources for performing cloud computing. So this is a little bit about cloud computing. Going further, a little bit more about big data analytics. So analysis is to be done there. So we can see this picture tells the complete story. My machines, I'm putting sensors on my machines and they are generating so sensors are generating data, and that data is I'm sending that data through internet. It is collected. Data is collected, and this data is not coming from one machine. It is coming from different sources. So I'm collecting that data and then I'm storing it. I require, so this is big data. I require higher storage capabilities. Of course, the cloud services, it is helping me, and everything is happening on the cloud. And on the previous slide, we saw that AWS and Azure are the service providers. They provide us services for that. And I also touched upon volume. So this is a huge data. So hexabyte. Now, what is hexabyte? So hexabyte. It is a unit of digital storage. We say megabyte, terabyte, petabyte, and next one is hexabyte. So it is a unit of digital storage. So a lot of data is generated, and data is also having a particular life. So data management is a big thing here. Huge data. Not only data is coming, but data we have to we the data is it keeps on accumulating and it has to reach end of life, and how you are discarding that data, all those things come into picture. But let's not get into that for the time being. So volume, lot of volume. And now what we do with that data, we need to do some research. So because we want to find out what are the trends. So we need to get some insights for the data, and for that we'll be doing analysis. So we apply certain tools and softwares to understand the data and find patterns. Once we do this, next we want to explain it to the general public, and for that we should be able to put whatever analysis we are doing, we should be able to put it on a dashboard so that everybody understands. The information is displayed, it is now represented in a visual manner so that it is easy to comprehend and explain. Okay, so this is overall what is happening here. Big data. So you can see big data and cloud computing, they are connected to each other. I can say it is something like this. In simple terms, cloud computing is a factory, and big data analysis is something, it is like work done inside the factory. Okay, so this is what we see here. All right, so it's related to now my problem is I'm dealing with data and I'm putting that data on the cloud. So what is the problem here? Can you identify what is the problem here? What is the problem here? Data, a lot of data, and I'm putting data, getting, doing analysis, getting information, everything happening on the cloud. So what is the problem here? There is one big problem, and that one big problem is, yes, surely, yes. Thank you so much for for pointing it out. Really lovely. Thank you so much. And it is the cyber security. This is a big, big problem everywhere. And we face it every day. So since now we are talking about IIoT, it is not easy. So cybersecurity is quite important. These are some of the threats that we face in today's, whenever you use computer, and this is whenever you're using computers and internet. So this all these things apply here also. You know very well what is malware. Malware is this is a so harmful software that damages or steals your data. So what is the solution? Obviously, you will use antivirus. Use up-to-date antivirus. Then phishing. This is also quite normal. You will be receiving some links, and they will you'll be tempted to click on those links, and moment you click, you are caught there. So phishing. So you have to be cautious that you don't click on all the links that you receive in your emails. Then ransomware. So they will lock some of your files and will ask of money for it. Please, my friend, please don't pay money. Just disconnect from internet and use your backup files and then go for antivirus. Then we have denial of services. You're starting a new company, you put up a website. Now the attack is something like this. What will happen? So you will see too much traffic coming on your site and your site is crashing. So what is the solution? So you have to go for firewall. So like that, so there are many problems and few of them I've listed here. Man in the middle is something like you're transmitting data and it is intercept in between. So this can happen when you use public networks. So use VPN and secure websites. So zero-day attack. So this is a bit tricky. So before company launches any patch, this is really difficult to tackle, but the only way at the moment is using up-to-date antivirus and fire uh, firewalls. Social engineering here, uh, you may get a call from a company guy and the facilities which you are using, and they will ask you for your passwords. Please don't share it. And then a big threat is threat from an insider. Imagine you are doing your bank employee, he's having all the information about you and it can be misused. But how companies are tackling this problem, they keep a track record of the unusual access of sensitive files, whether data movement is taking place. So they have a systems in place by which they check that only authorized persons are accessing the right information. Other guys are not unnecessarily peeping into information which is not meant for them. So like that, so cybersecurity definitely it is a big domain which you need to address if you are planning to embrace this latest technology of fourth industrial revolution. Okay, so with that information in the backdrop, now let's attempt this quiz. Which of the following scenario best demonstrates the combined use of big data, cloud computing, cybersecurity in an industrial setting? Thank you so much for your response, and I really appreciate that all of you are 100% correct in all these questions. Really, I'm impressed by your knowledge. Thank you and responsiveness. Thank you so much. Now, this is one case study which which I would like to discuss with you. I was fortunate enough to work with one scientist at NTNU Norway when I was there a few years ago. And this scientist, Qisheng Wang, he was working on RFID systems for improving traceability. That time, I'm talking. This is a bit low. This is a bit old thing. It's about 2012. That time it was a relatively new technology, but I saw this technology happening and now it is almost everywhere. So what he was doing. So just to explain you in simple terms on one product, he was keeping this RFID tag, RFID tag. What is RFID? It's a radio frequency identification tag. This tag is having all information about the product. What is the make, what is the expiry date. So you can put a lot of information on that tag. Now he created a smart shelf. So he created a smart shelf. On that shelf, the moment you keep this product, since it is having RFID tag, and on the shelf, there are scanners. So scanners will detect that RFID, some product with RFID tag is there. So what will happen? So this they have an inventory, and in that inventory it will be updating. So records are updated for particular product, how many units are there on the shelf. So this is a smart way of keeping inventory. And same way, if you remove the part from shelf, again it will be updated, and moment the number of items in that table goes below a reorder point, the order is also placed to the company automatically so that the products are received in time and there is no panic or we don't have any shortage of material when it is required. This was one thing which he did during that time, and now you see it is almost everywhere. Many companies are using same technology there, and I was really happy and fortunate enough to be part of that process to see everything happening in reality. Now, this was one thing, and another thing is the same setup, same product when it goes to the shop floor. He's putting sensors, he was putting scanners. It can detect where that part is in the workshop at any point in time. Not only that, when this part goes out and it is placed in the automobile, just to give you an example, suppose it is a steering. If you are fitting it to the automobile, it goes to the customer, and after 1 year they see there is a problem with the steering. Now, since the steering is having RFID tag, we can easily trace it back how it was manufactured, where was the problem, which is the faulty portion. No need to discard everything. We can track down everything. So that is why this RFID technology, we are saying, improving traceability. And this is how the companies, they recall the part in case they find some particular part is faulty. So RFID systems for improving traceability in the shop floor and also updating inventory, not only in the shop floor, but even when the product is delivered. All right, so thank you so much with this. Now we are coming towards the end. This is the most important bit, which I would like to highlight because this will give you a lot of ideas of how you can perform research in case you want to do research, if you want to pursue, say, a master's by research, or if you want to do by doctor of engineering research topics. So you'll get some idea here. And all these ideas are latest ideas. Okay. Marvin, I'll be concluding it in just maybe next 5 minutes. I think we have time.
All right. Thank you so much, Dr. Vishal, and for that very wonderful presentation. We've learned a lot about these things. So, yep, let me just take control of the slides.
I'll take just 2-3 minutes more to conclude it,
Oh,
if
okay.
you
Yep. Sure.
allow me that.
Sure. Sure. Sorry.
Yes,
Sure. No problem.
yes. Yeah, because this is the most important bit. I need to, yeah. So take control, go back. All right. So now here, yep. Let me grab my pen again. Huh. Now here, you see this one. This one, the first research topic I would say is it is related to a digital twin. So what we can do is imagine. I'll give you an example, and based upon that, you can maybe formulate a problem. So imagine you have a smart chocolate factory, and in that smart chocolate factory, each machine is having a digital twin. If something goes wrong, production is happening, AI will notice it immediately because this is digital twin. Everything is happening in virtual world. And IoT sensors, which are installed in the shop floor, they will send alerts. Okay, and then the system adjusts things itself to keep chocolates perfect. I'm bothered about the quality. So this is what can be done. This is just one example. This is how you can address issues and problems. This is one real problem in your industry also. You can take topics like this one. Coming to the second one, robotics. Now here, uh, imagine you have a robot which is working in a car factory. Now, and this robot is having AI camera installed along with it. So it will detect scratch and wrong parts using AI camera. And since we have built-in AI on my robot, on the data, so what it will do, it will decide instantly what to do, whether to stop the process, remove it, or what to do. It will be taking decisions then and there in real time, just like human beings. So this is again a big topic for research, and all these topics are latest topics. And all these topics require knowledge of at least two domains. So we can't now we have experts in different domains, electrical, mechanical, but we now in today's environment, you can see from this presentation also, we require guys, we require engineers who can work at least in two different domains. They should be able to integrate between mechanical and electrical and AI, things like that. So that is why I'm highlighting these topics. No doubt you can do research in separate each of these domains separately also, but I highly encourage you to be working on something which is combining two or three different technologies. Now coming to the third one, this one is related to additive 3D printing, additive manufacturing. So additive manufacturing, one example could be, suppose I'm creating metal, I'm working on metal 3D printing, I'm making jet engines. Now, so all the machines which are manufacturing, say, parts, metal 3D printers across the globe, they are sending data to to my cloud computing servers, and the system so the system is generating data, and that data is collected. And what AI will do, AI will say, it based upon my data, it will train the model, and it will say, if I don't slow down the printer, then a defect will happen. This is what is alerted to me. Not only alert, but it will also control. System will fix the problem before it ruins the part. So that is another thing. So it is not only I'm detecting, I'm solving the issue before that becomes a real problem. This one is quite close to my heart. AR, VR, digital technologies. Currently, I am completely immersed into it. Uh, this is also called immersive technologies. So immersive means you're not simply looking at screen, you are actually a part of the game. You get into things. So that is why this technology is also called immersive technologies. And what you can do, so maybe I'm wearing the headset, virtual reality headset, and I can see 3D models of my factory running in real time, and I can even touch and click and make changes on speed and stop it. Not only that, once I stop it, and if I'm increasing the speed, how much is the temperature rise? That information is also coming to me via augmented reality. So you see. So another big domain, very big domain to work in. Lot of excitement, new technology. So you can see it's quite fantastic topic. Last but not the least, still I like it very much, cybersecurity. So we want to have, so cybersecurity is important. So you can imagine a smart factory. So you're having a smart factory, and you're sending data. You send machine performance data to cloud, and somebody in between is capturing and then tampering with your data. So what you can do, you can still use blockchain technology to ensure your data is secure, and AI can keep a track, it can watch the system and says, okay, so everything is fine, or if there is a problem, it can show that there is hacking attempt, and it should block it so that everything is carried out quite smoothly. All right, so these are some of the topics which you can take for your research. And now it's time to conclude what we saw here. As we saw that fourth industrial revolution, you cannot, this is all technology driven. You can't escape from it. And The companies, they have to embrace this with open heart. And if companies are embracing it, you need to upgrade yourself in order to stay relevant in the business as an engineer. So I'll end this presentation by just one quote which is quite close to my heart, by uh, Klaus Schwab. So he is a founder and executive chairman of World Economic Forum. So he says, in the world, in the new world, it is not the big fish which eats the small fish. It's the fast fish which eats the slow fish. So be the smart fish and upgrade your knowledge, and be in touch with the technology and stay relevant in your field. Thank you. Thank
Ex-
you very much.
exactly. Very well said, Dr. Vishal. We should be the fast and the big, the fast fish, right? by gaining learnings through this kind of webinars. So thank you so much, Dr. Vishal, with that very wonderful presentation. So let me just take control of the screen on the slides.
Yes, please.
Okay. So, yep, for those who are interested, what are the courses covered by this topic? So, since this is a multidisciplinary webinar, it composes the mechanical, industrial, instrumentation, process control engineering. These are the courses on your screens that will cover this particular topic. So, first is the professional certificate course in mechanical engineering. We also have the professional certificate course in industrial automation engineering, a professional certificate course in chemical engineering and plant design. We also have our advanced diploma of plant engineering, advanced diploma of mechanical engineering technology, and advanced diploma in industrial automation engineering. So if you're interested to know more about these courses, please feel free to reach us here. Our course advisor team will be happy to assist you with that one. Okay, so yep. For the upcoming courses, we have this June, 10th of June, we have our professional certificate courses certificate course in industrial instrumentation, automation, and process control. Okay, and the other courses, as you can see on your screens. Okay, now for the Q&A section here, Dr. Vishal, maybe we can spend a few minutes about this one. We have listed some very interesting questions here from our attendees today. So let me just read the first one. Dr. Vishal, are we still good for a few minutes?
Yes, yes, sure,
Yeah, sure.
sure.
Sure. The first question would be, is digital twin the same as having a CAD model? That's coming from one of our attendees today.
Sorry, can you come again, please?
Sure. Is digital twin the same as having a CAD model?
Okay. So this was a really interesting one. In fact, when I started to work in this domain, I was also having the same opinion. Definitely, this is the first step. I would say it is the CAD model is in isolation. CAD model is not having any connection with the real machine. When we are saying digital twin, they are communicating with each other. So if I make some changes on the machine, it will be immediately reflected in my model. And if I do some changes in the model, it will be communicated. It will be replicated on the actual machine. So there is both ways communication happening, and this communication is happening in real time, and it is happening because of the sensors and connections that we have. So that this is a quite interesting question. Really, I appreciate. And one thing I would like to say, that if you want to work in the domain of digital twin, so you should always start with the first part. First part is try to put your machines on the internet. Start using IIoT, so Industrial Internet of Things. So use the Octopi and the Octoprint softwares to try. So they're quite simple to use. You don't need anybody's help. Maybe just a little bit of understanding will help you to make your machine. You can put that machine on the internet and you can connect it through your mobile. So this should be the starting point. Once you have established that, then you go for further steps. Maybe slowly you can go on adding different sensors and enhance the communication, and then you can definitely create a digital twin out of that. But you see, creating a digital twin is expensive affair. I should not be creating a digital twin of very simple machine which is inexpensive and the process is not costly. So we have to create. So that thing is important because it's expensive affair, and we need to think that is it worth it if I'm creating a digital twin of that machine. Definitely, I can say creating a digital twin of some nuclear reactor is definitely worth it. So that is my take. Thank you.
All right. Thank you, Dr. Vishal. Hopefully, it answers your question. The second question would be, what are some enabling technologies for IIoT? Does ML, machine learning, play a role? That's coming from one of our attendees as
Yes.
well today.
Yeah. Now, so actually, this one is quite interesting. I'll answer it this way. Now, machine learning is something which you can use in any of the domains. So you can use it in any of the domains. Uh, so for example, if it is a mechanical application, I can use machine learning on that data which is coming from the machines. Or if the application is different, say if it is a marketing application or sales application, I can I can apply machine learning on that also. Uh, Machine learning does not understand the application, it understands data, and basically it is, if you say it in simple words, basically it is trying to, you are basically, machine learning will fit on that data and it learns from there, and it is able to give you prediction. So it is as simple as this in simple terms. So you can apply, definitely machine learning you can apply in any of the domains.
All right, thank you so much, Dr. Vishal. And one last question before we actually wrap this up, because we have lots of incoming questions, Dr. Vishal, and we cannot really be able to accommodate them within our time frame. So just one last question before we actually wrap up, and then for those questions that were not answered, we will get back to you for the answers. All right, thank you so much. So the last question would be. Is VR the used for virtual meetings and virtual laboratories for EIT?
This one is quite interesting. I would like to, yeah, so we are not using it for any meetings, but definitely in our lab here,
Mhm.
I come from EIT's Melbourne campus, and definitely in our lab, we are using these virtual reality setups for labs, just to give our students a demonstration that how these technologies are, because we need to give input to our students how to use these technologies, and that we can give only if we provide them with these technologies. And yes, so yes, we have virtual VR headsets available at our campus.
Our campus. All right. Thank you so much, Dr. Vishal. And again, we would like to apologize to everyone. We can actually see we have lots of questions coming in, but unfortunately, because of the time frame, we cannot really accommodate them now. But we will definitely get back to you on this one. Dr. Vishal, thank you so much for your time and for sharing with us wonderful, this presentation today. And for those who are asking, here's the QR code and the link to the certificate of attendance. So thank you so much for staying with us until the end of this presentation. And then we will see you soon in our future webinars. Dr. Vishal, any parting words before we wrap up?
Yes, I would like to really thank Marvin you for putting up this wonderful show, and really I'm really impressed by the learners. They are really engaging in this session. It was really it was because of them I could deliver nicely, and I really appreciate effort of all the learners who asked me so many questions. And if I can see there are many questions still coming up.
There
So,
is, there is.
Marvin, I think like they can always write to me if my email is
Yes.
projected there, and
Mhm,
I will be definitely getting back to them. And definitely, I am also engaged in few
mhm,
agriculture-based projects, and also
mhm.
we are doing some biomedical projects. Definitely, yes. So I can
All
provide
right.
you even more insights. Thank you.
All right.
Thank you.
Thank Thank you, Dr. Vishal. Thank you, everyone, for those who stayed again with us. And again, here's the QR code and the link to the certificate of attendance. So we will try our best to send them to you for the next 4 business days. Okay. Thank you so much. And again, this is Marvin. Together with Dr. Vishal, we would like to thank everyone for joining us today's webinar and see you in our future webinars. Have a good one.